everybody, Kit Merker here from Noble 9, and I'm here with Idit Levine, who's the CEO and founder of Solo.io, and she's working in the service mesh space. Say hello.
Hi, everybody. Thanks so much for having me.
Can you tell me, and for those who are not familiar, maybe a little bit about Solo.io and how it relates to Istio and service mesh?
So, I mean, Solar in particularly, we'll be focusing on two areas, three pillars. The first one is the API gateway, and we have a API gateway built on top of Envoy called Glue, who is running in the biggest organization that exists in the market today. The other thing that we're doing, we have a product called Service Mesh Hub, which is basically a an abstraction layer to all the service mesh. So it's defining the API, all the service mesh, and you also have the concept of virtual mesh. So you can actually do two meshes, group them together, and we're doing all the work behind the scene. So you can do it with two instances of Istio, for instance, or you can do it with an instance of Istio and app mesh, for instance. And it's basically act like one big mesh. And the last one that we're doing is basically around WebAssembly. So as we know in the market, everybody that running either Glue or any type of service mesh, it's never perfect fit to any infrastructure. What you need is usually do some customization around it. And there is two ways to do this. One of them is do it to the control plane. And for that, you probably will write operators. So we have a kind of like an open source project called Autopilot that helping you to build an operator for service mesh. And the other thing is the data plane itself for Envoy. So what we're doing, we have a project called it's called a WebAssembly Hub, and basically what it's doing is giving you the ability to use WebAssembly in order to extend your data plan for any control plan like Glue or Istio or anything you basically want.
So maybe for people who are less familiar with service mesh, and you could explain, the use cases. I've heard that.
Sure.
It helps with kind of web and API and transactional workloads. I've heard that adding service mesh to Kubernetes can kind of just make it run better and give you better service metrics. I've heard that you can use the metrics from service mesh to get service level indicators that you can use for measuring reliability. Is there more to it, or maybe you can give your spin on kind of the purpose or the why, if you will, behind Istio and service mesh?
Yeah, I think that when you're looking at service mesh in general, you need to separate the implementation data from the actually use case. And I think that what's special about, like, I'm specifically passionate actually about the implementation details because I believe that the way service mesh is actually abstract and the problem that it's trying to solve can be leveraged for a lot more different problem, and we just basically just started, right? There is way more we can do. So in the nutshell, the way I think about it is that we're abstracting the network, right? I mean, we're basically putting this sidecar piece, which is a proxy, usually Envoy, but sometimes it's something else, next to each of basically a microservices, right? Or inside a pod, basically next to your application. And then you're doing it to a lot of them, right? And that's basically what abstracting the network. And you tricking the IP table that every traffic in and out will have to go through this proxy. So now imagine you have this proxy, and proxy can do a lot of stuff, but it's not extremely smart. You need to tell him what to do when the request is coming. So basically, by you putting that next to each application, right? And basically defining it as the gate to the application. So a microservice cannot talk to anybody without going through this, and cannot basically, and nothing can talk to him without going through this thing. Now we have this ability to configure the things. And because we basically can watch everything that's coming in and out, we can make a decision. For instance, is that okay that this microservice will talk to each other? Is that, maybe you want to do a retry, maybe you want to grab some logs, right? And anything basically that we want. And the beautiful of it, imagine it is basically like an X-ray. You can see everything that's happening, right? You can see, when you have bugs before, it could be inside the microservices, it could be on the latency, but you can't know. And what Service Mesh is giving you is the ability to basically put a sidecar next to it and then have control to see everything that's going in the microservices and on the transaction, right, on the pipe. So I think this is very, very powerful. And now, if we basically abstract the network, there's way, way more we can do, right? I mean, we can leverage it for security, right? Kenny cannot talk to people. You can leverage that for observability, right? You can say, oh, now I can actually see what's happening. So we can be smart about what's going on or debug it simpler. You can do stuff like, circuit breaking. So maybe something like chaos engineering could be very interesting because now instead of embedded library inside your code, you can basically just come on top of it and it injects basically, right? Well, injects information. You can do stuff that related to just special routing. I have two microservices, right? And I want them to talk to each other. So all of this, I think, becoming very, very useful, specifically when you're talking multi-cluster, that's even more complex. So the fact that you actually have right now two instances of meshes and how do you manage that? I think that's the big problem that people are trying to keep right now.
So when your company's looking across service meshes in multiple types, and there's multiple flavors and projects and solutions out there for service mesh, and maybe you have a unique perspective here on the trade-offs since you're working with so many of them. I haven't been able to get kind of a clear picture of the landscape. And maybe you could help me understand, the landscape of service mesh and how maybe the different trade-offs or the differences between the projects.
Yeah, now that's funny. Actually, so when we started working with service mesh, it was over almost 2 years ago. And what was clear to me is that would be big. But it also was clear to me that, first of all, it will take a while until it will get there, so like 2 years. And this is why we started with API. But the other thing that I actually realized is that it's going to be a very competitive ecosystem. And the reason is because when we started working on this, there was only Linkerd and Istio. And we just started, basically. But it felt to me that it would be big enough. And also when I looked on the beginning on the implementation of Istio, honest to God, I felt that they're going to be competition mainly because it wasn't the best piece of software back then. So when we looked at it, way, way better today, but just to be fair. But so when we looked at this, I basically said to myself, okay, we've been there before. We saw it going with, with the orchestration ecosystem, right? Kubernetes versus Mesos, all of this. And I tried to figure out what I can do that is not building mesh because I knew that it will be harder, that will be helpful. And then the HashiCorp guys, who we know very well, we have the same founder, and I know Amon Mitchell very well, basically reached out to us and said, here's the thing, we are going to create our own mesh, Console Connect. We're going to compete with Google and Istio. And, we helped them actually build the first Console Connect distro because they needed help with Envoy, and this is what my company is doing. So we start with that, and then it's kind of like hit me that instead of trying to build a service mesh, I don't want to try to build another service mesh to compete. What I wanted to do is to try to figure out what will be the next problem that people will try to solve when service mesh will be everywhere. And what I realized is that the first problem that people will want to solve is the fact that there is more than one, and more than one instance first. So like if you have two clusters, you will have two instances of service mesh. You have two instances of service mesh, it's already an orchestration problem. How do you manage it? Are you making that they upgrade? Version control and so on. So that's the first thing. But after working with Ashi, I realized that the problem will be even bigger because if someone will run HashiCorp in on-prem, and again, this is vision of 2 years ago, right? When they will go and want to use Google Cloud, they most likely will want to use the native solution there, which is Istio. So how is that going to work? And that's basically where we come with the fact that not only potentially we'll have more than one instance, it could be, but potentially to be a different one. Okay, so the mess that there is right now in the ecosystem, just to be fair, I predicted a long time ago. So now, after we announced this, AWS reached out and AWS announced UpMesh, right? So if you look right now in the ecosystem and you kind of look at this, 3 of the biggest cloud going to have a different meshes. Besides that, you have Kong with Kuma, right? You have Console Connect, you have Linkerd, and you have Istio. And that's for now, because I know that there is another one coming up. So now the question is, how is that, who is the winner? Why should you choose one by the other? And to be honest, it's a little bit frustrating that this is the ecosystem and this is the market, because to be fair, this is it's like amazing piece of software, like the idea of service mesh. And it's a shame that because of the mess, people are scared to kind of like adopt. And that's exactly what I try to prevent with service mesh out.
So would you contrast, I'm sorry to interrupt you, but I just want to get this idea. Yeah. Would you contrast the Kubernetes, you mentioned sort of the orchestration, and the outcome, was really consolidation, right? Now, in service mesh, I've heard people say that they actually don't anticipate there being a single winner. That the
I agree.
long-term kind of steady state of service mesh will be, multiple players playing side by side. But you've also kind of pointed out that they have a similar API. They actually can be orchestrated and work together across different instances. So isn't it kind of I don't want to say commodity, but isn't it kind of a technology that, it's kind of all doing the same thing? Or is there really a difference in terms of use case or flavor or something like that?
So, I mean, there's definitely a difference between them. The reason people doing it, the reason people, I mean, if I have to kind of like, if I will take your analogy to the orchestration and the result of it, I don't believe that that's what will be happen here. And mainly the reason, and I will be totally blunt here, and I'm very, very close to Google, mainly the reason was that Kubernetes from the get-go, the architecture of it was very clean. So it was a good building block to work together and basically get to where it is today. When Istio in the beginning, they make some architecture decisions that make other people wanted to compete because they didn't feel it's good enough, right? So now it's just in the matter of time, right? I mean, people started competing. They are already decided that they're going to create their own, and not to kind of like go and consider on one of them. I think it will be a hard one because each of them already invested, right? So to my opinion, they're going to be a lot.
You would say that those are market factors, not technical factors.
Yeah. Totally. So now let's talk about the market. The first two one that was, if you're looking at the one that, to my opinion, is the more advanced, is Istio and Linkerd. Linkerd is not based on Envoy, and that's a big, big minus to them. I think the reason, not because the technology is the minus. I mean, I think they're actually Rust proxy is pretty good. It's really good even. The only thing is that one of the advantage for Envoy, and this is why I bet as a company, is the fact that I thought that people will agree on it and will adopt it because Google did it. So I knew that there will be a good indication for that. And if you're looking today, and Lyft, of course, right, because it's coming from Lyft. And if you're looking right now today, I can tell you because I have tons of customers that are running on this. Basically, that's become the factor of Envoy as and proxy. And as one who's actually running in production a long time, I can tell you that we're leveraging the community, right? I mean, the fact that Google doing something is make me happy. The fact that Lyft doing something, or Stripe, or all those companies, I'm leveraging, as well as if I'm doing something, I'm bringing it back. So in the nutshells, we're just going way faster. So in the end, in the end goal, eventually, if you're a customer, what you care is about the use cases. What actually is the feature that you're getting? And I think you will get more with an Envoy-based a service mesh than something like Linkerd. So it's not the best. It's not about the best technology. Just about the market already, as you said, consolidate. It can go faster.
When you say, as a customer, I just want to clarify. So is that a directional statement about the amount of investment or the engineers behind it, or is that a statement about something technically about the fact that Envoy is part of the solution?
The fact that Envoy is part of the solution, and Envoy has this ability to be extended via add feature with something called a filter. And I'm reading filter and other people writing filter. Now there is an ecosystem and I can leverage each other. So in the nutshell, if you're buying from me a proxy, right, or Glue, right, API Gateway or Istio, what you will get is more feature and will be able to give you more things. I can give you a circuit breaking that maybe you will not be able to get with Linkerd right now. And now Google did an amazing work by actually bringing WebAssembly to Envoy. So again, now people can write their own filter very easily. That's the work that we did with WebAssembly Hub. That's a huge benefit to a customer, right? It's getting independence, which they cannot do right now with Linkerd, and I don't think they will do it anytime soon. So basically, if you think about it, what you're getting in turn eventually is a lot of power as a customer that can use a lot of good features that you need. So that's why I think that Envoy-based is the direction to go. So that's number one. So that's kind of like putting Linkerd in. So now there is a lot of Envoy-based service mesh. By far, hands down, the one that is the most mature and feature-rich, Istio. No question asked.
When you think about the trade-off between ease of use and industrial grade, we'll say, right? There's on the one side, and this isn't unique to service mesh. It's kind of, when you look at technology or products, you kind of have to think, okay, what's going to be easy to get started versus what's going to give you an industrial grade product. And when you're thinking about the spectrum, is that, how do you think about where Istio is in that spectrum, and where will it be in the future, first of all? And second part of that, I want to know, you mentioned that there are things in the direction that you're excited about, that it's easier to use or simpler than it used to be. Can you give me some specific examples? Can you tell me one or two things that really get you excited about the future?
Yeah, so I mean, I will start with the second one, maybe because I remember it, and then we'll go to the first one. So the second one, I think it's what I'm really excited about they doing. So it's very simple. I mean, I will try to explain that in the most not technical way that I can. But I mean, in the nutshell, Envoy can be extended, and you're extending by writing a C++ async filter. That's a very hard thing, and then you need to rebuild Envoy. That's something that we're doing very well, but to be honest, most of the people not. So we had, we needed to figure out how to attach it, because we knew as Google knew, and everybody that were using Envoy knows that not everybody can write an Envoy filters, but there is a need in the customer. So basically the way we did it, we basically said we will write it, right? We're writing those filters, they're very complex, we're giving you what we need, we're giving you a destroyer Envoy, oh good. Google tried to go to another direction, which is basically using something called Mixer. So basically every time that the request coming to Envoy, it's basically doing a gRPC to a Go server, and you can put some code there, right? Basically adapt there. The problem with that was that the performance, right? This is on the request path. It's very sensitive in terms of, doing a round trip suddenly with all this data that's being sent. And every time that you heard bad thing about scalability and Istio, that was the problem. The problem was the round trip. Every time that you want to change a simple thing in data, you need to send us all the body and everything to the mix. It just becomes very, very problematic. So one of the things that they decided to do right now, and again, I think this is great, is we basically brought a WASM support to Envoy. And now we will be able to basically make it way simpler to write a filter in Envoy in any language you want. It will run almost as fast as native code, and it will be safe because it's in sandbox. So all of this means that now you as a customer who want to, pin the header, let's say, or whatever, create your own filter, can do it in any language you want and very easily be up and running. And I think this would be great, because that will solve the biggest problem that Istio has in performance. So I think by they doing this, that will go a long way. So I think that it's becoming way, way, way better, because it's solving the major problem. I think that Istio is great in terms of stability and using in production. I have a lot of customers using it in production. I will say that in terms of ease of use, the main problem that I see is, I think that when Google designed the API of Istio, they wanted to make it that way that it's exposed a lot of power to the user. But by doing this, they chose an API that is a little bit implementation details, in the point of you can see, for instance, sidecar object in the API of Istio. But sidecar is implementation detail. Theoretically, it's not a feature, right? So in the nutshells, I think that it would be welcome to have some abstraction that define what actually you're trying to do. And what you're actually trying to do, you try to group a source, group a destination, and put the policy on the pipe. So I think that's how the API looked. And this is, for instance, what we did. So I think that that's complicated stuff, right? I mean, the fact that you need to understand how stuff works, usually to the users, make it harder for you to use. But it's still the best. So, to be fair, it's a trade-off, right?
Yeah, of course. I want to ask you, just shifting gears here a little bit, and I've been kind of exploring this topic with several people, so I appreciate getting your take on it as well. So last week, Google announced that Istio, along with 2 other projects, would be joining the newly found Open Usage Commons, and not the CNCF as some people had anticipated. And Open Usage Commons would be the neutral home for the trademarks. But for example, Jason McGee over at IBM, who's the CTO for the cloud platform at IBM, he said that this move, and I'm quoting, doesn't live up to the community's expectation for open governance. What do you think?
So let's understand, because I think it's important, it's educational to understand what does happen when you're giving a project to a CNCF. So what do you give? So usually those open source projects are already Apache 2, which means that the IP is not relevant here. So there's 2 things that is really relevant. The first one is the trademark, right? Who own the trademark? And the second one is the government. right? Like, I mean, you know, how does this project work? Who is defining what is the direction of this? And usually in CNCF, they're usually not detecting it. They're not saying, specifically the governments, they're not saying here is how it should be, but they're actually deferring it to the product, you know, to the product itself, or the project itself to define what is this government. Okay, so in the nutshell, if tomorrow Istio is Google giving Istio to CNCF, what CNCF will get is the trademark, and Google will continue with the open government, right? Which they have. So on the first day, if you're looking right now what Google did before, Google had an open, like it's Google with IBM and Lyft, they had already an open government. They have a very good one. Now, there is basically two committees there. One of them is defining the direction, the technical direction. And to be fair, and one of them is motherboard. And I can tell you that in both of them, Google, one of the Google is not the majority already, which means that, you know, by the way, government, you know, I will argue that IBM is part of it and they are the one who can change it and change the governments the way they want because they actually have a lot of power now. So that's number one. And number two, in the other one, they were the majority and they just basically suggested to stop that. And basically they came with a new rule to, first of all, extend it to 13 people. And second of all, make sure that non-company can be a majority. So if you're looking at this, to me, like, you know, if I'm trying to figure out as a user, do I want to use it or not? Policy aside, because as you probably assume, there was a good reason why Google did it, right? Which I can't share, but there was a very good reason why Google did it. So what you can say, forget about that. Forget about the politics. Me as a user want to use it. Am I in danger by going with Google, with Istio right now? I will argue that not, because the trademark is not Google anymore, right? They gave it to this thing, so that's done, right? So that's equivalent like giving it to the CNCF. It's exactly the same thing. Someone else owning the trademark, and open government, exactly like it will be if they will give it to the CNCF. Google will not be in the majority, and guess what? They will not be in the majority here as well. And I can tell you, as someone who's not like they're working a lot with the Istio community, I don't feel that there is any problem with the government. I don't feel that I'm not being heard. I don't feel that I'm, you know, so in the nutshell, it's the same thing. So now the question is why there is still a lot of noise in the market. And the reason is, to be honest, politics. I mean, it's not related to the end user is not being affected by that.
Right? Yeah, I think one argument I would love to get your take on this piece as well is that there's also the marketing and conferences and kind of the community, if you will, which is not, you know, quote unquote, owned by any organization or any group, and the affiliation is probably a bit looser for people, that they feel like they're part of, you know, the CNCF community or the KubeCon community because they go to those events and they're part of the SIGs, and there's a certain I don't want to say culture, but there's a certain, you know, group of people who are, and it's a worldwide group of people who are sort of all working in these areas, regardless of whether that affects the actual, you know, kind of mechanics, if you will, of the future of the project. There's a feeling, there's a sense of being a part of it and being in something new. What do you say to those people who are, you know, going to be at KubeCon and they care about Istio and they want to be a part of both? Is this a kind of a community tax on them to have to look at, you know, across multiple organizations, or is that just, I don't know, how do you see it?
I'm sad that this is going that way, but I will argue that, as you can say, I mean, the thing, as you said, and I should have probably mentioned it, that the CNCF is doing is basically giving a lot of marketing, right? And that's very, very helpful. It is helpful, but then again, look, to me personally, and this is very personal, I don't think that a project has to be, you know, I want to make sure that I will be able to use it. I want to make sure that I will be able, but you're looking at very successful projects like something like Ashi. Ashi has tons of very successful projects that was using in a lot of communities, and they're still not in a community, and this is fine. It doesn't mean that this project is not useful. Project like Vault, most of the ASI is using. So I don't feel that this have to be a must, right? And I'm not 100% happy about the fact that it started to be like you're either going to give it to a specifically organization or your project is dead. So I think that what, as I said, Google did is basically making sure that that's not going to belong to them. And I think that should check most of the people. And in terms of marketing, I do think that it's said that, you know, basically nothing Istio-like have to be involved. And I also think that it's a little bit wrong that projects that are not as part of the CNCF cannot be talked about. right, in a community. Because in the nutshell, all the idea with CNCF is to be the cloud native ecosystem, right? Even if they're not owning the project, it's still part of the community. So we'll see where it's going, but I believe that as a user, I don't see a big problem in terms of legal and governments. I don't think that this is a real issue.
Well, thank you for covering that topic. I wanted to shift back just for a moment as we're kind of wrapping up here. What do you see? You know, you've talked a little bit about the future of this technology and the different landscape, but when you look at some of the challenges that we're facing in the world right now around, you know, digital reliability, you know, everybody is pretty much not traveling, and so many things have moved online. So much of business and life and everything is now kind of relying on the internet and relying on services in the internet. As you kind of, you know, look forward a couple, you know, years maybe, how does service mesh fit into that future of kind of the reliability and consistency of services? Where do you see this kind of going over the next, you know, as you're just kind of looking ahead?
If you're looking at the service mesh, as I said to you, one of the biggest use cases that customers are talking about is security, right? MTLS and, you know, zero trust networking and everything that is doing. As well as help to debug problem. Now everything is on the internet and a lot of more people using it. I think that it's critical that you will be able to detect real quick problem and solve them and make sure that it's extremely secure. So I think that there is a big advantage of people who will use service mesh to serve their application. I think it will give them a way more velocity per se of actually be able to attack problem that exists and make sure that it's extremely secure. So yeah, I mean, I'm a big fan.
Well, thanks so much for being here, Idit. It was great to chat with you today.
Thank you so much for having me. I
And
appreciate it. Yeah.
everybody out there, this is Kit Merker from Noble Mind signing off.